So now let's look at the quiz for direct and inverse proportion. We have a few questions here and we need to solve them. We'll be looking at the solutions also for these questions. Here are some more. Let's look at the solution for the first question. The question says Divyansh reads 540 words in half an hour. How many words would he read in 8 minutes? So let's assume that he'll read W words in 8 minutes. And now we know that the number of words read is directly proportional to the time spent. So we know that number of words read by the time taken will be constant. So in the first case, we know he read 540 words in 30 minutes. So we'll say 540 by 30 is equal to, he read W words in 8 minutes, is equal to W by 8. So now we cross multiply and we get W is equal to, okay, we first simplify the left hand side, which becomes 18. So W by 8 is equal to 18, and then cross multiply, W is equal to 144 words. Let's look at the second question. It says 6 pipes fill a tank in 120 minutes. Then how much time will 5 pipes take to fill the same tank? Now we know, looking at the statement, we can clearly see that if the number of pipes filling the tank are reduced, then the time taken would increase. So let's first assume that it takes X minutes to, 5 pipes take X minutes to fill the tank. And now we know that the number of pipes is inversely proportional to the time taken. So we say number of pipes multiplied by time taken is constant. So in the initial case we have 6 pipes and 120 minutes. So 6 into 120 will be equal to 5x. So we get x is equal to 720 by 5, which is 144 minutes. Moving on to the third question. A model tower is 90 centimeter high when the actual tower was 150 meter high. So we have a tower of 150 meter and we make a model for that which is 90 centimeter high. Now if the height of a door in the tower is 3.5 meter, we need to find out how high will be the model. Now let's assume x to be the height of the model door, and we know that the model height will be directly proportional to the actual height. So we say that actual height divided by the model height would be constant, and so if we say actual height, or we could also say the model height divided by actual height would be constant. So we've taken the model height, which is 0.9 meter, divided by 150, which is the actual height, is equal to x, which is the model height of the door, divided by 3.5. So we get x is equal to 0.9 into 3.5 divided by 150, which comes out to be 0.021 meter or 2.1 centimeter. Now the idea of taking this, where we are saying model height divided by actual height is constant, instead of taking actual height by model height, is just that we wanted to keep x in the numerator. Otherwise we could have done other way around also, which would also have resulted in the same thing. Now the fourth question. Hostel has food provision for 24 days for 75 students. If 15 students leave the hostel, for how many days will the provision last? Now let's assume x to be the number of days for which the food provision will last when we have 15 students leaving the hostel. Now we know that number of students will vary inversely with the number of days the food provision will last, because if there are more number of students, the food provision will finish earlier. So we say number of days multiplied by the number of students is constant. So when we have 75 students, it takes 24 days to finish the provision. So we'd say 24 multiplied by 75 is equal to The number of students now is 60 because 15 students leave the hostel. So we have 60 into x. So that gives us x is equal to 24 into 75 by 60, and that comes out to be 30 days. Fifth question. By walking 5/3 of the usual speed, a student reaches school 20 minutes earlier. We have to find his usual time. So let's assume t to be the usual time taken and s be the usual speed. So we know that the speed is varying inversely with the time taken. So we can say speed into time taken will remain constant. So we can say now that the child is walking at 5/3 of the usual speed. So we say 5/3 of the s, where s was the usual speed, multiplied by t minus 20 because he reaches the school 20 minutes earlier. So t minus 20 is the time that he takes with this speed. That is equal to s multiplied by t. So we can simply cut s with s and we get t minus 20 and we cross multiply. So we get t minus 20 is equal to 3 by 5t, which gives us, on obviously taking 3 by 5t to the left hand side and we take 20 to the right hand side, we get 2 by 5t is equal to 20 and t is equal to 50 minutes. So this is the usual time that the student takes to reach his school. Moving to the last question. 10 men can complete a 50-meter road in one day. So they're constructing a road and they complete a 50-meter road in one day. How many men should be deployed to finish 175 meter in one day? So the time that we're taking is remaining the constant. So we know that if the work to be done is more, the number of men required will be more. So if we assume x to be the number of men deployed for the task, we know that the number of men is varying directly with the task. So number of men divided by the length of the road is constant. We know that 10 men when we have to construct 50-meter road. So we say 10 by 50 is equal to x is what we need to find out, number of men for 175-meter road, divide by 175. So x is equal to 10 into 175 divided by 50, which comes out to be 35 men are required to finish a road of 175 meter in one day. Friends, I hope you enjoyed the session. If you find it useful, please like it and share it with your friends. You can visit us at our Cool Smart Learning website and post your queries there. And please subscribe to the Cool Smart Learning channel for getting updates on the new sessions. Thank you.